Hello, can you hear me?
Yes.
Yes, we can hear you. Hey, hello everyone. My name is Vikas, and yeah. So, first of all, before we start the session, I'm just wondering, where are everyone coming from? From the background perspective, please raise your hands if you are from data background, data science, data analysts, analysts, or whatever, anything related to data. Please let me know if you are from data science background or data related backgrounds. No? No one? Okay. Anyone who's from software background, like computer science background or something like that? We have one. Okay, someone who's having MS in analytics. Interesting. Okay, that makes sense. Someone is data related as well. Okay. Um, okay, someone who is, let's say, from engineering background. No? From science background, like a degree in science, it could be physics or maybe mathematics background, something like that. Okay, interesting. Okay, actually, there are two multiple. Again, this is just introduction to machine learning. So I'm just again wondering, how should again there could be multiple introductions to machine learning. Um, I can introduce it from very different perspectives. So finally, one last questions. How many of you actually know about machine learning, or understands what machine learning is at a very broad, basic level? Okay, Nick knows it. Okay, what else? Anyone else? No, completely new to the topic, right? Okay. Riddhi also knows it. Okay. I'm assuming Diara should know it as well because you're from analytics background, right? MS in analytics, kind of, to some extent. Yeah. Okay. Interesting. Okay, so a couple of people. Okay, so let me just go to the whiteboard and try to explain this whole thing. Um, yeah, as what machine learning is and why is it important? What are the potential applications? Okay, so let me just kind of give you a very broad kind of an overview. I don't want to get into a lot of mathematics over here. I mean, this is just kind of an introduction to the whole topic. Okay, so let's try to understand why do we use machine learning? Okay, I'll begin with the question. And the question is going to be, let's say if you are throwing something at a particular height from a particular height, okay, whatever that object is. Okay. I'm sharing the whiteboard. I'm assuming that all of you can see my pen and my whiteboard. Is it so? Yep. Okay. So if you're throwing something from an object, from a particular height, if you're throwing some object from a particular height, right? And I'm asking you to tell me how much time would it take for this object to reach the ground, right? I can give you the weight of an object and some character, whatever you ask, right? Characteristics of an object or, the wind and whatever, right? Would you be able to tell me the exact time that it would take to reach the ground? How much seconds it would take or milliseconds it would take? Can anybody tell me that? I'm not asking for the exact calculation. I'm just wondering if you know that we can actually get the solution to this problem. Yara is saying yes. Okay, so I'm expecting that all of you can unmute yourself. Just start telling whatever you want to tell. So because it's interactive session and it's just an introduction, so I want it to be very interactive. That would be really helpful for everyone, right? So you can just unmute yourself and have comments or just have discussion around the topic. Okay. So so people are saying yes. How would you know about that? How would I be able to find out the time? Anybody who can unmute and tell me? No? Okay. So basically, if you remember from very, college level physics, we found out that there are some Newton laws of physics. And based on those Newtonian laws, we can find out the gravitational force and the overall laws of motion, following the laws of motion, following the laws of motion, we can calculate the exact time, right? And that was the reason where we can actually predict and correctly predict, you know, how to land on Moon and Mars, right? Because we already know these different laws of motion by Newton, right? So these are very kind of a traditional physics kind of a stuff that we already know, right? That allows us to actually work with the world around us, right? So again, before I move forward, I really want you to understand this kind of a basic problem. And yeah, um, so Jabbar is asking, anybody else is also having similar kind of a problem? Kumala can see it. Jabbar, can you rejoin? And let's see if it works. Yep. Because if I kind of remove it and kind of restart it, I'll have to write everything again. Okay. So please try to do it again. And if it doesn't work, then let me know. I'll find a way. I'll write it again. Doesn't matter. Okay. Nevertheless, this is an important point. Okay. Um, you can calculate the time that it takes by following the laws of motion. There is no randomness involved in it, right? Okay, now the next question. If I ask you, let's say, that was something related to physics, right? Your physical world, right? Now let's try to understand chemistry, a little bit of chemistry, right? So let's say you have water, you have, let's say, it could be petrol or diesel, whatever, right? You have some other chemical substances, probably, you can call it, any kind of acid or whatever, right? I can add on, right? Multiple different kind of substances, chemical substances, right? And if I combine them in a particular proportion, if I tell you that, hey, what if I'm adding 10% of water, um, 27% of petrol or whatever, right? And 33% of acid and so on, right? If I just continue doing that, right? And I ask you to tell me what would you get at the very end, right? Now, based on the knowledge that you have, again, based on the laws of chemistry, I would say there are some laws over there as well, right? And there is some kind of a knowledge that you already have, like what kind of a chemical reactions would happen and blah, 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 right? All of that is predetermined. It's a knowledge about the world that is already established knowledge about the world, right? So using those, you can actually answer the question, what would happen? You will be able to predict what's going to happen, right? That prediction is 100% correct in this case as well, right? And in this case as well, right? Doesn't matter. I can come up with any other kind of a example over here, right? But mostly, these predictions are 100% correct when when you have established knowledge behind it and the process is not random in its nature, right? Let's look at some of the problems which cannot be solved and which has yet not been solved, right? Let's look at some of the problems and try to understand the nature of those problems and try to understand what is the common between those problems, right? Because that will serve as a motivation for you to learn machine learning, because machine learning is there for you to understand why we use machine learning in the first place, right? So over here, let's say um, you want to move from position A. Let's say you want to move from position A to position B, right? Now, while moving, there could be, again, it's a real world problem, right? So it's a location A and it's a location B. Of course, when you're moving from this place to another place, in between there will be different factors which will affect your total time that you will take from moving from position A to B, right? So it could be weather. We don't know what could be the weather. It could be, the number of other cars. I mean, again, that's what we call the traffic, right? So the traffic would definitely affect your time, right? That you would take, and some other factors as well. I can list some other factors as well, right? But even if I tell you exactly that this is going to be the weather, this is going to be the exact traffic and blah blah blah, would you be able to tell me the distance between A and B? There are so many randomness involved in this process that there is no exact kind of a law or exact kind of a formula which will tell you the time that you would take, you know, moving from point A to point B, right? And all of those factors have a lot of randomness in them. So you really can't perfectly predict what the weather is. You can't perfectly predict what the traffic is going to be, right? Traffic is just a number of people at a particular time at a particular location, right? So at this particular location, how many people are there? We cannot predict, right? It depends on the mood of people, right? Somebody just had a mood to go to some place and they just, went on or whatever, right? Somebody was going somewhere else and then they suddenly realize, oh, I want to go on that route. And boom, there is another car, right? So how would you exactly know what's the amount of people, what's the amount of traffic and blah blah blah? It's not possible for you to kind of analyze and perfectly determine all of the factors that would influence the time and then use some kind of a formula to determine the time, right? So in that case, it's not that easy. So for that reason, there is a lot of randomness in it, right? And because of this lot of randomness, we use machine learning in order to learn the relationship or predict, which is not really exact, and we will make some errors, but try to learn the relationship between the output and the input. So all of these variables will become input, and the output is going to be the time that we are trying to predict, right? The time that it would that a particular user would require, a particular person would require to move from A to B. Make sense? So machine learning is used in that particular case scenario, right? Let me try another case scenario. Again, you can send me a message of a particular industry, and I can give you different examples from particular industry as well, right? So another kind of a scenario could be, let's say you have customers, right, coming into your store, okay? And now you're trying to understand how can, and again, you have a question that how can you increase the number of, how can you increase the, let's say, um, number of, revenue. So you want to increase the revenue, right? So maybe you want to kind of, um, you know, give preference to some particular type of customers or whatever. So that's also another kind of a machine learning problem because you cannot really predict what's going to happen, what is happening with all different type of customers, right? So maybe you have young customers. So again, that's another kind of a task. You really want to determine what kind of customers have what kind of properties. So maybe you have a very, of course, very high kind of revenue customers. These are high revenue customers. These are medium, again, medium revenue customers, mid revenue customers, and then it's a low revenue customer, right? And you want to kind of determine different customers into these four different baskets, right? And then try to understand them, right? So let's say the very high customers are particular customers which has properties like they're very young, by young, I mean they are between 18 to 35 or 18 to 40, right? And then secondly, most of them are, let's say, the proportion of, let's say, a woman is more than men, right? Usually these are the kind of studies that they found, right? Then the third one could be some other things like the people who are generating more revenue are the one with some kind of a stable job or something like that, right? So again, these are different kind of features of customers, right? That you are interested in finding out which customers are generating more revenues. And then based on that, you need to determine how can you attract these kind of customers in your shop, in your store, right? So that the revenue is increased and the profit is increased and so on, right? So again, this is another kind of a machine learning problem where you're trying to determine the patterns. It's a very different kind of a problem than this one, but again, it's another kind of a machine learning problem. And again, you cannot make use of any kind of a physical formula or some kind of economic formula. There is a lot of randomness. You really don't know so many of factors which is affecting the behavior of humans, right? So you cannot really predict the behavior of humans, right? And just, I mean, again, this is one of the biggest application to either understand the behavior or modify the behaviors, right? So let me give you another example of machine learning. So one of the greatest kind of a recommendation algorithm where no other company is beating it is the TikTok algorithm, recommendation algorithm, right? Again, it's a very interesting machine learning problem. So what TikTok is basically doing, technically speaking, right? So they are taking humans, they are trying to model every single human. Now, how do you model a human? How do you model the overall psychology of a human being? Is it even possible? Well, it's not possible, technically speaking, right? But they are trying to approximate it, right? With exact mathematical formulas, it will be very, very difficult. I don't know by when would we be able to, create a single model which will determine the behavior of a human. It will be very difficult, right? But still, TikTok is trying to do that. And one of the complication with modeling human is what? Is its evolving desire, right? So it's quite possible that you're desiring for something right now, and maybe after 1 hour, there is completely different thing that you're desiring for. And you suddenly get bored from one particular thing, right? And you want something completely different, something else, right? There are so many things. Again, I mean, this whole problem is extremely difficult. But if you are able to do that, if you're able to understand humans, I can tell you there is a lot of revenue in. And for that reason, this company is generating a lot of revenue. And it's one of the top companies. And you're seeing that, right? So how do they do it? Again, it's a separate kind of a machine learning problem, machine learning algorithm. So all of these uses some kind of a machine learning algorithm, right? So I talked about this one where you're using some kind of a supervised machine learning problem. This one will be a little bit of more unsupervised machine learning problem. This one has a lot to do with semi-supervised machine learning problem, right? And a little bit of reinforcement learning as well. So these are some terminologies that I'm kind of throwing here. It really doesn't matter. The important point over here is that you have different kind of algorithms that you can use for different kind of tasks that you have, right? Different kind of problems that you have. And I can count on hundreds of different problems in real world that requires machine learning in order for you to do some prediction, to generate some value out of your data, right? So all of these problems that I'm discussing has some kind of a data. We need to have a data to use that data, right? So over here, usually they would kind of look at all of the other humans which are very relevant and very similar to you, and the content that you're seeing in the last 5 minutes, and based on the feedback that you're giving, the likes, the dislikes, the favorites, and your followers, and blah, blah, blah. All of these different kind of things play a role that becomes a feature for you in order for a TikTok to recommend some kind of a video, right? So they will have some kind of a preference. I can go on and explain this algorithm in much more detail over here as well, but that's not the place over here for me to explain the algorithm itself. Of course, I mean, no one knows exactly what is happening under the hood. I mean, what is the exact algorithm, but we can make some assumptions. And based on my own observation, I have some neat kind of assumptions around this particular algorithm. Nevertheless, the point here is that you can use this algorithm for recommendation. This is TikTok is one of the specific example, but the more generic kind of problem is what we call recommendations, right? And for the very first time, I think the recommendations were being used by Netflix. In order for Netflix to recommend for you the movie, right? What is the movie that you should watch that you will kind of like, right? And there was a very huge price associated with someone, associated with the algorithm, who would kind of create that algorithm for them, right? And then in that time, people kind of created really nice ideas and so on. So it's a separate set of algorithms, right? Now YouTube also does that. I mean, almost every single company does it, one way or the other. Even if you don't know it, it does it, right? Even the website, I mean, the websites that you visit, any website that you visit, right? Usually, there will be different designs of that website, and they will choose one design versus the other depending on the click-through rate, right? If you go to the website, if you will click on a particular item or not, that depends on that depends on the design of a website. So they assume that the design itself has a lot of say and has a lot of influence on someone kind of becoming the customer or not, right? So they would choose one design A versus B, right? Using some kind of an algorithm where we could say recommendation. So you're recommending design A or B for a particular customer, and different customer might see different designs depending on their interactions and so on, right? So all of this is, comes under the category of machine learning, right? Now I can talk about healthcare, right? Or maybe even language and images. I mean, what not? I mean, just name it, and I can give you different examples of how machine learning is being used there, right? So if you have any particular kind of industry in mind, please send me a message so that I can explain that as well. But generally speaking, let me explain something in healthcare. Actually, let me not explain other examples. I mean, I've already kind of explained a lot of examples. If you ask me, I can show you some other examples as well. What I really want you to see over here next is just to understand how machine learning works, right? How easy it is. Like, although it solves these different kind of complicated problems, but the whole workflow is not that hard. So I want to show you a little bit about the workflow of a machine learning process. So before I get into that, anybody having any questions around what we discussed? Okay, perfect. If it makes sense, then let's continue. So the overall workflow is you need some kind of a data for machine learning. Without data, there is no machine learning. Okay, data is the key. Going back to our original problem, which I kind of explained in the very beginning. If you want to kind of model something where you are throwing something from a particular height and you want to find out the time that it would take to reach the ground, let's say you are trying to solve this problem in 1500s. How would you do that? Because again, at that time, Newton's laws of motions were not kind of established, right? So how would you solve this problem in 15? Of course, I mean, there were no computers at that time as well, but assuming that you don't have Newton's laws of motion, right? How would you try to solve this problem? Well, the first thing is you will create the data for it, right? So what you would do is you would first of all find out that what could be potentially, again, this is very important and you need to understand that, okay? That's where we are saying that we are engineering features. This particular topic is called feature engineering. It's a big topic in machine learning, by the way, okay? And that's usually one of the most important steps, okay? Because there is a term in machine learning where they say garbage data, garbage model, or garbage output. quality data and quality output, right? Quality predictions, right? So it's very important to have a quality data set, right? And the first step is to engineer quality features, right? How do you engineer different quality features? It basically means features which would actually affect the output that we are trying to predict. In this case, we are trying to predict the time that it would reach, that it would require to reach the ground, right? Now, what could be the potential variables which will affect this time?
Like gravity, air quality, something like that.
So gravity, okay. What else? So what is the force of gravity, right? So let's say you don't have the gravity. Again, let's say even if you have the gravity. So gravity would be one thing that you need to know, right? That's a constant basically, right? 9.8 mile per second square, whatever. That's an acceleration, right? Nevertheless, gravity, then what else? Of course, height is affecting it as well, right? Maybe again, because gravity is a constant, so usually you don't take it into account, right? Then the another thing could be the weight of an object. Probably again, we are assuming that that is affecting the time, right? Then not just weight, the size, the density of an object probably, you know. And then again, maybe the airspeed, right? Also the air direction, probably. Again, who knows? I'm just kind of guessing, right? And what other things could affect the time? Think about it. Well, even if you don't, if you just consider that these are the 5 different features that would affect the time, the question then becomes, how would you how would you conduct an experiment for machine learning? How do you collect the data? What would you do? What will be the next step?
You do experiments.
Yep. So you will just empirically throw different objects of different weight from different height, right? Uh, at a different time, so that there is different airspeed in different direction, right? And different objects of a different density, right? So you will have variations over here. So you will throw different objects with all of these different properties. So you will have 6 different columns, right? So 1, 2, 3, 4, 5, 6. And then final one, you're trying to predict the time, right? So this is what you're doing. Sample 1, 2, 3, 4, blah, 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 right? You can have a lot of samples, by the way. Let's say 10,000 samples, right? So you're conducting this experiment 10,000 times. So you have 10,000 rows, and every single row consists of 6 different values of the input features and then the time that it took, right? Does that make sense? So you have 10K rows with 6 different input features and 1 output feature, right? The output feature is time. The 6 input features is what potentially could affect the time, and 10K is the total number of experiments that we have done. Any questions around that? So this is how you collect the data, right? So this is what we call a tabular data, right? Because you have a data collected in a very tabular form, okay? By the way, before I move on and explain the next steps of a workflow, the first step is always to collect the data, right? Right? Before I kind of move on, I am just wondering, what other data types do you think we have in real practical kind of a world? So we have tabular data sets like Excel sheets, right? Then you also have data set that you want to work with called language data set, right? So you have plain English written. It's not organized in a table form. It's just documents, different documents, right? That's what we call language data set. Then you also have images. right? So you need to work with that kind of data as well. That's a separate discussion as how to deal with these data sets, okay? Then you also have videos. Well, videos is nothing but a collection of images, right? You have speech data set, right? Speech is like speech signal, right? The voice data set, right? Then you have graphical data set. You have graphs instead of tables. Those graphs would represent different things. If you are talking about chemical kind of elements where you have H2O, I mean, again, or any other kind of a benzene or whatever. So again, if you have read about, there is a very kind of C6, again, C6, H6, and then there are different kind of chemical compositions. You would find out that basically they all have these different kind of graphs, right? So all of these are nodes. So again, I mean, I'm not going to get into the detail of that, but basically there will be a weird kind of a graphs, and if you're going even more complicated, so it can become even more complicated like that as well. So that would be a single kind of a graph for a particular chemical substance, right? Right. And that chemical substance, again, if you're doing a drug discovery, that's a big topic in machine learning as well, right? So you have to work with this kind of a data set as well, right? How do you work with that? Again, that's a separate discussion. But the point is, you can have all these different kinds of data sets as well. It's not just tabular data set, the traditional kind of a data set that you're aware of, right? You need to know how to deal with all of these other kind of data sets, okay? And make it work for machine learning, okay? Then again, I mean, I can get on and on. I mean, I have made it really simple, but you can really kind of extend it to your specific domains depending on wherever you're coming from, right? If you're coming from some engineering background, then this speech data set is very much related to any other sensor data set. If you have sensors in your system, that will be very similar, right? And this images that you have over here is very similar to, I mean, again, you have satellite images, and you can work with those special kind of images and work with that as well, right? And so on. I mean, I'm not gonna get into further details, but I hope so you see that, right? And this language itself can be any language: English, Arabic, Chinese, whatever, right? French, Spanish, blah blah blah. But apart from that, it can be actually a coding language like Python or blah blah blah, right? And you can use that in order to learn some kind of relationships from there as well. Okay, so in this particular case, to solve this very simple problem, we have calculated the whole data set, which is in a very tabular format. Okay, but this tabular format data set is what we call a structured data set. Okay, so the data set is very structured, but in reality, you can have a very unstructured data set. Okay, like that. Okay. For example, for the customer segmentation that I discussed a little while ago, the data can be in tabular format, but it is quite possible that you have different reviews by different customers, and there is some other kind of a descriptions of customers, so you have a language data. And it can be combination of a language and table and so on, right? Okay. So now, one more detail over here. Although it's not necessary at this point because you already don't know about it, but for those of you who already knows about it, the structured data set or the tabular kind of a data set is very well learned by one of the most kind of a well-known and famous machine learning algorithm called gradient boosting trees. Again, there are variations of that, but essentially that's the base algorithm being used, okay? This is one of the best algorithm to learn from the structured data set. And for all the unstructured data set, there is an algorithm called the neural networks. Okay. And particularly because there is a lot of unstructured data set and there is a lot of value in it, this neural network is modified in way too many different techniques, right? So this neural network in itself has become a big thing, a very big thing, right? So a study of really kind of a complicated neural network is what we call deep learning. Okay. Now, deep learning is a subfield of machine learning. although the neural network is one of the algorithm of a machine learning, but it has become so big that we study it under a separate subject that's called deep learning. Make sense? And it usually works very well with all of these unstructured kind of a data sets. And whenever it's about tabular kind of a data set, neural network doesn't perform very well in comparison to gradient boosting trees. Okay. Now, this is a very basic overview. But again, I mean, usually you have some kind of a data. And then after that, the next step is usually to process that data. So this is what we call pre-processing. Pre-processing means you would clean the data, right? It means if there are some samples with different features missing, you will kind of fill it up. You would kind of remove the null values. You would remove the outliers, analyze the data, and blah, 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 right? So pre-processing is just about cleaning the data, right? And then usually you will do some kind of an exploration after pre-processing. Exploration is done in order to understand your data, the different kind of relationships that exist, right? And based on that, you can do some feature engineering as well, okay? So pre-processing and exploration could also give you further feature engineering. In the beginning, when you're creating data, you're doing feature engineering. But even after you have created data and after you're doing the analysis with the samples that you may have, you can create further more and more features as well, okay? And once you have created a feature, that's where you kind of, prepare the data. Once you have prepared the data, you would you divide the data into different splits. Again, that's a separate discussion around why we do it. But, you will, let's say, use 80% of the data for training and 20% for testing. Basically, it's a training, validation, and testing. But for now, I'm just making it much more simple, right? Training and testing, right? Which means that the 20% of the data is what you will never touch. And you will use this training data in order to fit a model. So the next step is to fit the model, right? By fitting the model means learn the relationship using some kind of mathematical algorithm, whatever that algorithm is. For now, I'm not talking about it. It could be gradient boosting trees, it could be neural networks, it could be linear regression, it could be random forest, it could be support vector machines, it could be whatever, right? Once you have found the relationship, you will use that model in order to evaluate it by using the testing dataset. And if you're happy with it, you will just deploy it, right? And then people will start using that model in order to get the prediction, and that will generate the value for you, right? So that's, again, a very basic kind of an overview of the whole machine learning process, okay? Now, let's talk a little bit about these models that I talked about, right? But before I do talk about it, any questions around what we discussed until this point? No? Make sense? Interesting. Okay. So if it does, then let's continue. Perfect. So now let's talk about different kind of models that are being used in machine learning, right? So you have used usually kind of, as I said, you can have a supervised kind of learning problems, as I discussed. There could be, let's say, unsupervised learning problems, right? And then, as I discussed, there could be semi-supervised learning problems as well. Right. Well, these are three different kind of problems. In the supervised learning problem, again, it's all about data. So they majorly, kind of differentiates with data. How would you identify if a particular problem is a supervised or not, or it's unsupervised or a semi-supervised kind of a problem? Well, you can just look at the data, and from there on, you can know that what's happening there, right? So in the supervised learning problem, basically, you have the input, which I'm kind of determining by the X. X is a matrix which shows all of the input data, right? In our previous case, the 10,000 rows and 6 columns were the X, the input data, right? And for each of the corresponding sample with 6 features, you have a corresponding output to Y, right? That becomes our training data. So the Y will have a matrix of 10,000 samples and one output. So there is a single output that you're predicting, the time that you're predicting, right? So usually if you have a problem where you have the input, and the output, and you're trying to find a relationship that exists between them so that you can predict the output next time given a particular input, right? That's what we call a supervised learning problem, okay? If the output is continuous feature, then that is what we call a regression problem. If it is a categorical feature, we call it a classification problem. Okay? These are two important kind of problems: regression problems, classification problems. And basically a lot of machine learning is done around that, okay? Then in unsupervised case, you have input, but you don't have a corresponding output. And unsupervised learning is very famous because you have a lot of, finding out the corresponding output is a very costly process, and people usually are not able to afford these different kind of experimentation. So you don't have the output. You're trying to capture the patterns just from inputs, right? So people can do that as well, right? That's what we call unsupervised learning problems. Basically, there are two different kind of algorithms in that as well. So one kind of algorithm is what we call clustering algorithms, and another kind of algorithms is what we call dimensionality reduction. I'm sorry for the very bad handwriting. Okay. Now let's talk about semi-supervised. Is anyone else having the same problem where they can't see the screen? Kyle, you can see? Okay. Jabbar, can you see? I'm not sure if Jabbar is with us. Okay, Nick, awesome. Okay. So, okay. Let me kind of, again, I will miss all of the writings over here, but I'll try to do it again. I hope so you can see my whiteboard now. So I was talking about the supervised learning problem, unsupervised learning problem, and semi-supervised learning problem, right? And I did kind of talked about different algorithms like regression, and then there is classification, right? Over here. And over here, there is clustering and dimensionality reduction. All right. Awesome. That's great. Thanks. You're welcome. Okay, so in semi-supervised, these are the kind of problems where you have the input, but the corresponding outputs are not available for all of the inputs, okay? So of course, I mean, you will have some inputs, but the corresponding outputs are not available for all of the inputs, right? So for example, there is a user A, let's say, and this user A has watched movie A, but not movie B, right? And also has watched, has given rating to movie A to be 4 and movie C to be 3 and so on, right? So some of the movies are being watched by this user and some of them are not, right? So this is kind of not really kind of filled in data, right? So it's a semi-supervised. There is some level of supervision because we already know some information about this user, right? But still there is a lot of information still missing, right? So that comes under this category of semi-supervised, right? So again, there could be a different problems, but let's say even if you're talking about recommendation, right? There are different kind of algorithms for recommendations, right? Of two very famous, old school kind of recommendation algorithms are what we call content-based algorithm, content-based recommendations. And another one is collaborative filtering, okay? So again, these are all different algorithms. Again, I'm not getting into the details of these different algorithms. I'm just kind of letting you know that these are different algorithms to solve different kind of problems, right? So always the first step is to identify what kind of a problem you're dealing with, supervised, unsupervised, semi-supervised, right? Then important point is to understand the nature of our data, how do you collect the data, do feature engineering, whatever, and then determine what kind of algorithm would perform very well on a particular data set, right? So these are the different algorithms. Now, going back to the supervised category, because that's one of the famously used category, right? I'm going to get into a little bit of detail around that, and then I think we can stop. Actually, I'm not going to get into the detail of these algorithms because it will make you more confused as how do that work. I'll just give you the names of these, right? So there can be different algorithms in this particular regression and classification category. For example, you can have a linear regression. You have a logistic regression, right? You have decision trees. Again, those of you who are already aware of that, please let me know. If you want to ask some question, I can get into that as well, right? Then you have random forest. You have gradient boosting trees, GBT or G whatever, right? And then there is neural networks. As I said, neural network itself has become a really big kind of a thing. So it's neural network has a special kind of a that's come under the deep learning category, right? Because there is a lot of variations of neural networks, right? So you can have CNNs, you can have LSTM, right? You can have transformer-based models, right? And blah, blah, blah. So that's a separate story, completely separate story, okay? But yeah, that's some of the algorithms in supervised. In unsupervised, you have other algorithms like k-means, you have hierarchical algorithms. Again, there is a lot of details around that as well. For dimensionality reduction, you have PCA, you have t-SNE, you have UMAP, blah, 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 right? So again, these are all names of different algorithms that we will get into the details around when we are working with the machine learning algorithms. But the main point is that the whole idea is to understand what kind of a data you're dealing with. You must have a very clean data set. So you need to do some cleaning, some pre-processing and stuff. And then you need to understand these different algorithms for different kind of tasks and how they work, right? Right now, I'm not gone into the detail of any algorithm. For example, if I want to get into the linear regression, that's one of the most famous one and a very well-known kind of an algorithm out of all of the academic students, right? No matter where you're coming from, usually people knows about that, right? So linear regression is a linear model where you have the output prediction y hat equal to, again, I can call it y, whatever, a y equal to mx plus c if you have one input feature and your output is also y, right? So in order to, again, this is a linear model, but we have to learn the parameter m and c. How do we do that? By using some kind of a optimization algorithm called gradient descent, right? So how do we use the gradient descent? By taking the partial derivative of some kind of a error metric. In this case, the error is going to be mean square error with respect to m and also with respect to c. Now, that partial derivative would give us two different formulas, right? And we will use both of these formulas in order to learn the best parameters, okay? Once we have found the best parameter, that's the whole learning process, right? That's the overall mathematics behind it, right? But in practical use case, to be very honest, you really don't need all of that mathematics. There is just 3 lines of code in Python that can allow you to do that as well, okay? But again, that is something we can look into later on some other day, okay? So that's it. If you have any question, please let me know. Otherwise, yeah. we've already shared with you the link where you can find the recording of this session as well. So yeah. So let me just. So yeah, if any question, please let me know. Otherwise, I'll see you soon. Thank you, Kamala. Take care. Thanks, everyone. Take care.